Hello, I'm Nate George. I'm the program director for the Masters of Science in Data Science program at Regis University. And this is our week one walkthrough and lecture. So in this video, I'll just be kind of touching on the high points of the presentation and from the expert materials for week one. So as you've already seen, we have this content tab in most of our courses. And within there, we've got our materials broken out into weeks. Each course is 8 weeks. So typically we'll have 8 sections in here for the different weeks. And then within there, we've got an overview and outcomes, which has a short description of the week and learning outcomes. And then in the next page, we have a to-do list, which has everything we need to do. And so each week there'll be some sort of discussion and assignment, and usually some sort of reading materials or other from the expert learning materials. So in this week one, we have a presentation, which I'll kind of touch on the high points here. This presentation is in this walkthrough section here. So I'll kind of skip this first part here. We have several faculty from a variety of backgrounds. There's more details in there. Most of the time, the places of world class you're going to need are this content area, discussions, assignments, and occasionally the quizzes area. In terms of coming to Regis, there's a lot of benefits of being here. So one big benefit is networking. We do get some alumni reaching out to us, asking for recommendations for people for hiring. We also have a career center. Faculty have connections. We also have this handshake platform here where you can look for jobs and get connected. So good networking opportunities. We have a lot of resources such as the library, which my favorite aspect of the library is this Safari Books link. So just looking for the computer and information sciences research guide on the library page. The first link there is the Safari Books link, which is learning.o'reilly.com. There's a ton of books here, and that's where our reading for this first week comes from, for example. So that's a nice resource to have. We've also got a learning center, which has a writing center where they can help you learn to improve your writing, and they'll proofread your papers and things. The Career Center, we've got our physical campuses. So the main Lowell campus is actually an arboretum, which means it has a ton of different trees on campus. So if you get a chance to walk through campus, you can see all the different trees. They're all labeled. And there's a very nice chapel, which has weekly masses, or you can just walk in during the week. Also, another advantage of the program is accountability. So you can do a lot of the same materials on online courses like Coursera and things like that. But when you're in an online, or when you're in a course with us, and you have faculty here and other students, it keeps you more accountable and on track. And I didn't put it on here, but also, you're getting a credential, so that's helpful in getting a job and things like that. We also have the Jesuit aspects of our education because Regis is a Jesuit university. So we'll always include aspects of ethics, things for social good, and education of the whole person. And lastly, almost all the work in the data science program is project-based, and there's not very many quizzes or tests. So this first week, we're looking at applications, the life cycle of data science, roles of data scientists, a little bit about big data, a little bit about ethics, and then kind of a review of Python basics. So the data science process, here's one diagram of it. So in general, we kind of start off with asking a question. That could be something that has to do with our business or organization. So, for a university, we're always asking about how can we make our courses better and improve graduation rates and improve enrollment rates and things like that. So one of those questions could be interesting. Next, we always have to get the data, which often involves either working with someone else or doing it ourselves with a variety of methods like accessing databases. Then we always need to understand and explore the data, which involves a lot of visualization, statistics, and just kind of getting in there and getting our hands dirty with the data. Then after that, typically we'll do some sort of modeling with the data. This doesn't always have to be a part of a data science project, but kind of the more powerful parts of data science are using things like machine learning and AI. And that involves modeling data, fitting a model, and then using that somehow, maybe deploying it, say, as an API so other people can access and use it. And then there's also always needs to be some sort of communication to say like stakeholders. So we'll come back to that in a little bit. In terms of what data science is, so there's a lot of different opinions out there and a lot of different Venn diagrams. But I kind of like this one that I found recently. This shows data science, the perfect data scientist is in the middle here. The overlap of these four skill groups: communication, statistics, programming, and business. And you can kind of see all these different other groups here, which have some of these skills, but not all of them. And yes, it's pretty tough to get all these skills. I guess, yeah, I would probably say the programming stats are the hardest skills to acquire out of these, but they're all important in their own way. So communication, obviously super important, as well as business or domain expertise. So sometimes instead of business, we'll also call that domain expertise, which if you're working in, say, the hard sciences, or maybe some other field where it's not really business, like say it's a government application, then you might not really have a business aspect to your work, but there's some sort of domain expertise. And then programming, so we can do data science without programming, and it's getting easier over time to do that. But part of the reasons to do programming is that scaling, so you can scale up algorithms, machine learning algorithms, you can scale them to handle any arbitrary size of data inputs and things like that. Also with state-of-the-art tools and techniques, you really need to be able to program to take advantage of those. Any of the pre-built tools are going to use things that are more established. So if you want to customize things and use cutting-edge tools, you really have to use programming. And then there's also this little tidbit. I've heard several people say in a variety of settings that a difference between an analyst and a data scientist is that the data scientist can program or code, whereas the analyst might just be doing kind of more one-off analysis on data sets using tools like Tableau or Excel, things like that. But you'll also see data science jobs out there where the primary tool used is Excel. There might be some kind of nomenclature issues in the field where people call themselves a data scientist, or people are trying to hire someone who they think is a data scientist when really it might be more of an analyst role. So those kind of roles get mixed up a lot, analyst and data scientist. I guess the meme is on a separate animation, but anyway, I don't know if you can, I'm not sure if my picture is covering that or not, but yeah, so I mean, anybody can do data science, you just have to learn these different skills, combine them in the right way, and put in some work and effort and practice. So the process, again, we kind of looked at a simpler process earlier. And here's another kind of one, which is shown to be a little more circular. So some sort of asking a question, identifying a problem, getting data, some sort of analysis, which might be exploring the data, also making visualizations, things like that. We might make some sort of model or statistical implementation of something, and then we might deploy it. And we always need to communicate our results and maintain what we built, if it's some sort of service. And a lot of the times that'll include machine learning, but it doesn't always have to. But some examples of where a data science process might be used with machine learning are things like cluster analysis or clustering. So customer segmentation, grouping customers into groups so we know how to market to them or do things like that. Anomaly detection can be used in things like cybersecurity, for example. And then predictive analytics is a big one where we're trying to predict something, say like a health outcome, or maybe categorize something. Applications are pretty wide reaching. I got a bunch of them listed here, but I mean, anywhere you have data, you can usually use data science. One example is in health. So we can use basically computer vision techniques to do a lot of things with health images. In this case, we're combining a whole bunch of different data sets to try to predict Alzheimer's disease onset. But these sort of techniques also get used for detecting, say, like brain tumors or pneumonia. So that's kind of an overview of data science. We'll cover the readings in a bit, but be sure to go through the readings to learn a little bit more about data science. A lot of the times people will say part of data science is big data. So being able to scale what we're doing to big data. And there's typically three things that we think about with big data: volume, variety, and velocity. So volume being the size of the data, variety being different types of data, and then velocity being how fast it arrives. So we might have streaming data from a website where it's coming in very fast, or we might have batch data where we're getting data delivered once a day from something. There's a whole bunch of tools for working with big data. We can actually just use Python big data packages. That's kind of a first easy step. So once you learn Python, then you can use libraries like Dask, H2O, several more, and those can just help you scale some already written Python code to big data. Others are Spark, which has a Python package called PySpark, or you can use it in R through Sparkler, or many other ways. Hadoop, of course, is classic, but has kind of been, at least in the programming side of things, Spark kind of took over Hadoop. There's also a ton of cloud tools like AWS and so on. And then, of course, R also has big data libraries. Whoops, and forgot to bring up this thing, but yeah, so these kind of three different dimensions of big data are shown in this visualization, and kind of with some more details of examples of what they are. So back to the process, data science process. We can also think about this process in terms of project management for data science projects. And one of the kind of classic data mining project management strategy is CRISP-DM, the cross-industry standard process for data mining. That's shown here, where we have this kind of circular diagram with 6 different steps. Same idea: ask a question, understand your data, understand your data, prepare it, do some sort of modeling, like maybe machine learning, evaluate how things are going, maybe go back to these previous steps. All throughout those, it's very iterative. And then at the end, we have some sort of deployment, which involves maybe scaling it so that customers can use our machine learning algorithm, and also some documentation and maintenance and all that. So yeah, so we'll kind of look at this first week. We'll look at kind of business understanding and data understanding. And then in future weeks, we'll get into preparation, modeling, and we won't really touch, and a little bit of evaluation. We won't really touch deployment. That's kind of deploying a machine learning algorithm, for example, is a little bit more advanced. So we won't be touching that exactly in this class. And sorry to keep flipping back and forth, but one more thing I just remembered here. So we end up spending a lot of our time with data preparation, data cleaning. Some polls will show data scientists spend 1/4 to 3/4 of time, but other people say they'll spend more like 75 to 90% of their time cleaning and prepping data. So that's a big fraction of the data science work. But some of that's being moved into data engineering jobs. Ethical concerns, there's a whole lot. We have an entire class on this, MSDS600. So we'll talk about it a little bit in this class and basically every other class, but that class will really delve deep into it. There's privacy concerns in terms of data, and a lot of, oops, I didn't know if there's another image here in the middle. And then a lot of issues with bias in AI. So with machine learning and facial recognition and all these different things. One example of some privacy concerns has to do with phone apps. So phone apps tracking your location is can be a slippery slope with data privacy concerns. In terms of tooling, so we're mainly focusing on Python in the program. We also have a little bit of SQL and a little bit of R. So Python seems to be gaining traction as the top data science programming language. And it's a little bit different style programming language than R. It has a big network effect because as Python grows larger, more people use it, more people build tools for it, and that feeds on itself. And so, you can see from this survey here from Kaggle, a data science competition website, that most people are responding that they use Python, also SQL, and then a lot fewer people are saying they use R. And a whole bunch of other languages get used as well. But Python in general is kind of a little bit better for certain things, especially neural networks, serving websites, interacting with cloud tools. And of course, it works great for machine learning and things like that, as well as big data. But both of these are what's called Turing complete languages, so they can technically both do anything. But R has a lot of other tools that are pre-built for classic statistics. So like a t-test just comes built into R, whereas it's not built into Python and things like that. And then there's a bunch of other tasks where libraries are pre-built that might make things easier for R or Python. So Python has this little poem called the Zen of Python. If you do import this in Python, it'll print out this and a lot more stuff. But yeah, it's kind of just meant to be a simple and easy to read language. And it's been around for 30 years or so. And so it's got some network effects going on. Looking at the number of Stack Overflow questions, we'll get to what Stack Overflow is shortly, but basically the number of questions about how to use Python is much higher than for R. And it's, they've both been growing a lot, but this is a logarithmic scale. So the number of kind of activity surrounding Python versus R, at least on this programming support website, is different by about a factor of 10. And then there's some other languages shown in here. But the more users, we got a bigger community, so more support, more tools, things like that. So as you're working through the program and working through projects, there's a lot of different resources for help. So the first one is whoever's teaching your course, your professor or instructor is there for you. So don't feel afraid to reach out to them and ask for help. Other students in the class can also help too, via the discussions, or you could just message them directly. Perhaps, it's always good to build up your network too. So that's a good way to meet people as well. Your advisor and success coach in the college, also there to help more on the side of administrative things. And we've got our learning commons along with the writing center and tutoring center, which I mentioned earlier. That can be especially helpful for writing. Documentation for Python packages we'll get to, and Stack Overflow is another great site for support. And then of course, don't be afraid to just search on the internet for something. And one thing about documentation is that the guy who created Python, Guido van Rossum, so he was also the benevolent dictator for life for a while, which is kind of funny because he resigned from that title, but he created Python, and he says he uses the documentation all the time, and so do other people who have written other software packages. So the documentation is always really helpful, and we'll kind of learn how to use that a little bit today. One last thing is that sometimes I'll come across broken links, maybe in some of our courses or elsewhere, and that's just kind of a part of how the internet works. Things are always changing, so we do our best to keep them up to date, but it can be difficult to do that. So a couple of resources for dealing with that are these two websites, archive.is and archive.org. It's always good to check those for a broken link. You can see if you can find that resource in one of those. And so for documentation, yeah, we'll kind of look at this a little bit more, but documentation, finding that through a search engine and also using Stack Overflow is just part of doing data science, basically. Books can also be super helpful for, especially for like fundamentals of statistics, machine learning, and things like that. A couple of free books here I've listed, which have to do with stats, and a couple of other books which have to do with Python and machine learning and things like that. So go ahead and check those out if you're interested. This R for Data Science book is free, and so that's a nice resource as well. So this first week, we've got a couple from the Expert Jupyter notebooks we're going to look, which the first one looks at a basic Python review and crash course. And then the second one, we'll look at some EDA and data understanding. And then we're going to use those the second demo with the EDA and our reading materials to complete our assignment, which is basically a similar EDA task on a different data set. And then we also have some discussions to do. So for reading this week, there's a couple of them available through the library here. So if you check those out, you'll see that there's a little bit of a Python review in there. And then there's also some like what is data science, basically. So Python is basically a kind of a foundation for you for data science. So you should really work on it and learning it and mastering it over time. And if you're taking 1 or 2 years to complete the program or just working on the certificate, that gives you some time to get better at Python as well. And we don't really officially teach too much of it in the program. So you're kind of expected to be learning some of it on your own. And here's a couple other resources. If you're still feeling kind of shaky on Python, you can do this Udacity Intro to Python course, which I think is supposed to take something like 8 to 10 hours. And it kind of goes through pretty much all the basics in Python. And if you're feeling a little bit more comfortable with it, you might do this Kaggle course for a refresher. And then there's a ton of other resources which are listed in this Fast AI forum post. So yeah, use something to just kind of improve your Python skills every month or every week or even every day. And that'll really help you a lot. And there's a bunch of other resources here I've got listed for doing that as well. So that's it for the presentation. I think I'll stop this recording here and we'll start another one for from the experts.